So, say it's about Christmas time, and you were thinking about setting up some pretty lights out in your front yard using your big flagpole you have there. But you were thinking about modeling it after the big trees you usually see in Times Square, like the big Christmas tree light up Christmas trees they have there. So you were thinking to maybe get some strings of light, tie them to the top of your flagpole, and lead them down to the ground to get a cool looking Christmas light show. But you don't know exactly how long it would need to be from from the base, and how long the string would need to be from the top of the flagpole to the ground itself. But you know the angle you want it to be at, and you know the height of your flagpole. So how would you find the length of the string and how far apart from the base of the flagpole it would need to end up? So, the problem here is to find the length of the string from the top of the flagpole to the ground here, which is S, and also the length from the base of the flagpole to the end of the string touching the ground, which is G. And the one we're going to do first is finding S, which in order to do that, you would need one of these two sides and its opposite angle, which here we have the length of F, so we need X, which we have, thankfully. We have measured that the the degree of the angle X is 60 degrees, and the length of F is 22 feet. So since we have this 60, this 90, and this F at 22, we can use the law of sines here, this one and this one specifically, to figure out what S is. Which, this law of sines, you may be wondering how we can do that. The law of sines basically means that each of these sides divided by the sine of its opposite angle is equal to every other side divided by its own opposite angle. So f divided by the sine of x is equal to g divided by the sine of y, or its opposite angle. So f divided by the sine of x is the same as s divided by the sine of z as well, which that makes f divided by the sine of 60 is equal to s divided by the sine of 90. And here you can see that f measured up to be 22 feet in height, and the sine of 60 degrees here is 0.866, where the sine of 90 is just 1. So that's 22 divided by 0.866 is equal to just s. So 22 divided by 0.866 is 25.4, as you can see here, which is the length of this side and the string of lights that we need. So after that, we need to find G right here using this triangle. You're wondering how we're going to do that now. This is just as easy, but you learn this a lot sooner. It's called the Pythagorean theorem over there, which you simply need the other two sides in order to find a third. But that's usually done as a squared, which is this side, plus b squared, this side, is equal to c squared, or the hypotenuse, or this long side here. And we already have a squared and c squared, but we need to find b squared, which means instead of doing it like this, we do it more like this here. You have the normal a squared plus b squared equals c squared, but in order to put b squared over here and c squared over here, you would subtract b squared from this side and put it here, and subtract c squared from this side and put it over here, in order to get a squared minus c squared is equal to negative b squared. But for this, it is the absolute value of f squared minus s squared is equal to negative g squared. The absolute value is there since the length from the base of the flagpole to the end of the string can never be negative since it's always going in a positive direction. So to find this, it is 22 squared minus 25.4 squared is equal to negative g squared. And 22 squared is 484 minus 25.4 squared, or 645.16, equal to negative g squared. That comes up as the absolute value of negative 161.16 is equal to negative g squared, which then is just plain old 161.16 is equal to g squared. But we can't have it be squared, so we need to take the square root of that and the g squared to get 12.69 is equal to just g. So then here you can see that we have both sides needed. We have the length of the light and the length of the ground in between the light and the base of the flagpole. So we have all three sides needed to make this work how we want it to.